Hi, I'm John. In this lesson we'll be discussing order and absolute value of real numbers. Let's look at our specific objectives. Our objectives are order on a number line, absolute value, and properties of absolute value. Let us look at a number line. In this example we have negative pi, negative 1/3, the square root of 3, and 3 2/10. If on a number line a is to the left of a real number b, then we say a is less than b, or a is less than b. And if a is to the right of b, we say a is greater than b, or a is greater than b. On this number line, we say that negative pi is less than negative 1/3, because negative pi is to the left of negative 1/3. So negative pi is less than negative 1/3. 3 2/10 is greater than the square root of 3 because it's located to the right. And we'd write 3 2/10 is greater than the square root of 3. Let us look at an example. Write the numbers on the list in numerical order from smallest to largest and use the calculator if necessary. First we will write them in decimal form, rounding them off to the nearest tenth. Square root of 8 is about 2 8/10. Negative 4 is fine. The square root of 3 is about negative 1 7/10. Negative 2 is fine. Negative 5 is fine. And the square root of 6 is about 2 4/10. And then we have 3. And now we can order them. Our smallest number is negative 5. Our next number is negative 4. Then comes negative 2. Negative 1.7, then 2.4, 2.8, and then 3. And then go back to our original numbers, was negative 5, negative 4, negative 2, minus the square root of 3, the square root of 6, the square root of 8, and 3. The following symbols are variations on the greater than and less than symbol. We have less than or equal to, we have greater than or equal to, we have not less than, and we have not greater than. You can write 8 is greater than or equal to 6 because, in fact, 8 is greater than 6. And you can write the inequality 7 is less than 8 is less than 9, read 8 is between 7 and 9, or 7 is less than 8, and 8 is less than 9. Let us continue the lesson by talking about absolute value. The distance on a number line from 0 to a number is called the absolute value of that number. It is written and read the absolute value of a. The absolute value of 5 is 5. And the absolute value of negative 5 is 5 because 5 and negative 5 are each 5 units from 0. Negative 5 is 5 units from 0, and positive 5 is 5 units from 0. Let's take a look at an example. Let's evaluate each expression. The absolute value of negative 5/8. That is equal to 5/8 because negative 5/8 is 5/8 units from 0. B, the negative of the absolute value of 8. So this negative sign stays with us, and the absolute value of 8 is 8, and so my answer is negative 8. Here we have the negative of the absolute value of negative 2. Well, this will be the negative of this value, which is 2, or simply negative 2. The absolute value of 2x, if x equals pi, absolute value of 2x will be the absolute value of 2 pi, and since pi is a number greater than 0, we simply get 2 pi. There's an algebraic definition of absolute value. Let's look at it. For all real numbers a, the absolute value of a is equal to a if a is greater than or equal to 0, and it's equal to negative a if a is less than 0. Let's try an example. Write the expression without absolute value bars. We want to evaluate the absolute value of 2k minus 8 if k is less than 4? Well, if k is less than 4, 2k minus 8 will be less than 0. So going back to our definition, 2k minus 8, since this will be negative, will equal to the negative of 2k minus 8. And that will be negative 2k plus 8, or the absolute value of 2k minus 8 can be written as 8 minus 2k. There are some properties of absolute value that you should be able to use. Let's look at